Okay, so we're looking at arithmetic sequences here. An arithmetic sequence is one where you add the same amount or take away the same amount between any term in the sequence. So here are some examples of that. You can see that I'm always adding 2 to get between any two terms of the sequence. Here I'm always taking away 5. And here I'm always adding the same amount. I'm always adding 0.75. Now there are sequences where you would be multiplying or dividing between each term in the sequence, but generally they don't come into the syllabus until 6th form. Those are called geometric series, but we are here focusing on arithmetic series, where you are adding or subtracting. So the thing that defines an arithmetic series is that the difference between any two adjacent terms is always constant. They always have a common difference. So in this case, it's always plus 2 to get from any term to the next term. In this case, it's always minus 5. So you could think of it that I'm adding on negative 5 to get from any term to the next term. And in this case, as I've said here, it is always add on 0.75. So how about if we want to find out the 100th term in this sequence, and we don't want to have to work through all the preceding 99 terms to get there? Well, what you can see is that for the second term, I started at the beginning and added on 1 difference. For the third term, I added on 2 differences. For the fourth term, I added on 3 differences. So whichever term I'm at, I've had to add on 1 less than that number of differences. So if I want the 100th term up here, for example, I would do 5 plus 99 differences. Now each difference is 2 in this case, so I'd have 5 plus 99 steps of 2. If I wanted the 100th term for this series, it would be 50 plus 99 lots of minus 5, because every time I go along another term, I take off another 5. If I wanted the 100th term of this series, it would be 1.5, my starting place, plus 99 lots of 0.75. So the formula for any term in a particular series is always that UN, so that means the term which is in position n. So I've just spoken about n is 100 for the 100th term, is always the starting value of the series, the first value in the series, plus n minus 1, so wherever I want to end up in the series, minus 1, differences. So if I wanted the 100th term, I would say U100 is the first term plus 99 differences. If I wanted the 500th term in a series, I would say U500 is the first term plus 499 differences. So for my sequences above, if I were to just drop the bits that I know about the sequence into this formula, it would give me a formula where the only thing I would need to know would be the n to work out any particular term in the sequence. So for this formula here, for this sequence here, the first term is 5, the common difference is 2. So any term in that sequence would be 5 plus the position of that term minus 1, lots of 2. For the next term, any term in this sequence would be 50 plus the position of my new term, minus 1, lots of minus 5, because every jump forwards by 1 step added minus 5. In other words, it took 5 off. And for my third series here, the formula for any term in the sequence would be 1.5, the starting value, plus position in the sequence, minus 1, lots of 0.75, the common difference for that term, that series. So the first question, or the first part of an arithmetic series question, would almost always ask you something about find a particular term in the sequence, find the value of the 500th term in the sequence, something like that. And for that part of the question, you would use this formula, which is not on the formula sheet, so you've got to learn it. The second part of a question about an arithmetic series is quite likely to ask you about what happens if you add up all the terms of a series up to a particular point. And the formula for that, which is on the formula sheet, is that the sum, in other words, what you get if you add them all up, of a particular number of terms, so it might say find the sum of the first 100 terms, in which case n would be 100, is however many terms you're adding up divided by 2, brackets 2 times the first value in the series plus the number of terms you're adding up minus 1 times the common difference of the series. So this part is very similar to the formula that you had up here. So, for example, with the series we had above, the sum of the first 5 terms of my first series, well, I'm adding up 5 terms, so I would start with 5 over 2 into 2 times the first term in the series, which in this case was 5, plus n minus 1, so I'm adding up 5 terms, so that's 5 minus 1, lots of the common difference, which is 45. Now I know that doesn't give you much of an advantage here over just typing 5 numbers into the calculator, but if the question had said add up the first 5,000 terms in this sequence, using the formula wouldn't have become any different at all. It would have been just as easy, whereas typing 5,000 terms into your calculator would have taken a while. So you might want to pause the video here and see if you can do the calculations for the sum of the first 5 terms of the second and third series above. And your answers should have been 150 and 15. So I'm adding up 5 terms, so 5 over 2 in both cases, 2 times the first term, plus number of terms minus 1 times whatever is the common difference for that series. And similarly, what about if I'd wanted to add up the first 100 terms just for the first series up here? So the first term is 5, the common difference is 2. So add up 100 terms of that series. The sum of 100 terms is 100 over 2, so n over 2, 2 times the first term in the series, plus the number of terms minus 1, lots of the common difference. So it would have been 10,400.